Okay, good afternoon, everyone. Thank you for attending this session, Protecting Your Data with SQL Ledger. So, uh, thank you for the sponsors of this conference. Without the sponsors, this conference would not be happening. This is me. You can see my contacts on the side of the screen. You can see my personal site. This second link is a newsletter that I'm using to produce, and it will be a pleasure to connect on social media. Get my contacts, connect, let's keep connected. My name is Dennis Torres, I'm a data platform MVP. I work for the Tower Software in Malta. I'm a trainer with some Azure certifications, and I'm a multi-data platform user group leader. So the agenda today, we'll talk about what's Azure SQL Ledger, how Azure SQL Ledger works, provisioning the SQL Ledger database, the types of tables that we have with SQL Ledger, Azure SQL Ledger system tables, which will help us, a demonstration, and we'll talk about external storage. So, what's Azure SQL Ledger? The first point is, why do we need SQL Ledger? Some solutions require a higher level of data integrity. I'm not talking only about be sure that the data is correct. I'm talking about being sure that no DBA or no IT professional inside the company could tamper with the data. And no one could be able to tamper with the data without leaving an audit trail. That's the point. A higher level of data integrity. You need to prove your data has not been tampered with. Sometimes you need to prove and provide this proof for an audit. Maybe in a process, in a juridical process, and something like that. Blockchain could do that, but blockchain is decentralized and this can be an overkill. It's too complex to manage solutions. So we need some other way to build that. Some examples of needing. Here in Malta, where I am, there are many iGaming companies, and one common pattern on these iGaming companies is the wallet of the player without the transaction made by the player. And the software needs to calculate the balance, the current balance of that player. And these companies don't trust on this solution if a DBA can update or data, if an IT professional can update or data, so the wallet is considered not trustworthy enough. And some of these companies were looking for third-party solutions to solve this. And now with SQL Ledger, we have a solution for this. Another interesting example, pest tracking. Let's imagine a care factory. And someone bought a car from this factory and had an accident. This guy could sue the factory, complaining that his car had parts which should be recalled, but he was not advised about it. So the company needs to provide a tracking of which pieces were used in his car, but this for a process needs to be completely tamper proof. Needs to be tamper proof. And a single table in a database would not be completely tamper-proof. No one could ensure that a DBA in the company would not manipulate the data in favor of the company. That's what SQL Ledger brings to us. A solution where this level of tampering is not possible. Some companies were using third-party solutions as workarounds for these problems, but now it's not needed anymore. So, what is SQL Ledger? Each transaction is recorded as a history. We have a history of each transaction with the database. Digest blocks are created for the transactions. Digest blocks are saved externally to the database, and this external storage needs to be an immutable storage. So we can check the database with this external storage at any moment. And the digest can be used to verify the integrity of the database. So how Azure SQL Ledger works? How? The transactions are recorded in a system table. Digest blocks are created for the transactions. Digest blocks are asynchronously transferred to external storage. This point answers some questions about performance. So this transfer to the external storage is asynchronous. Verifications can be triggered regularly. So you can schedule the verification of the database. Provisioning Azure SQL Ledger database. So, the provisioning Azure SQL Ledger database. So we provision SQL Ledger to get the provisioning of an Azure SQL database. Inside the provisioning of an Azure SQL database, there is this option to enable Ledger on the database. Then, if we choose to enable Ledger in the database, we can choose the external storage for our Azure SQL Ledger. I will use initially the Azure storage account, but it's also possible to use Azure Confidential Ledger. You can't change the first configuration after this. You can disable Ledger or enable Ledger after having provisioned in the database. But you can change the external storage at any moment. So types of ledger tables. Updated ledger table. The name tells everything. The name is telling us this table accepts update. So, keeps a history of our operations that we are executing, based on temporal tables. You may have heard about temporal table. I will not dig so deep about this, but please send me questions later and we continue the conversation about this. A view retrieve information about the operations. So, the history is saved, but it's not very easy to query. So for every table, a view is built to retrieve the operation executed on our ledger table. So this image illustrates this scenario. We have here an external application and the table. This is the ledger table, the updated ledger table inside the SQL Server. The application will insert records inside this table. And according the records change, the records are updated or deleted, they will be moved to a history table about what already happened with this table. To query the operations from the history and the main table is not easy. It's not an easy task. So the ledger view makes it easy. We can consult and can query the operation using the ledger view. And behind the scenes, every change, every inserted or change on record is generating a record of the transaction and a block, a digest block which forms a chain of hatches of this block, ensuring that our data has not been tampered with. Asynchronous, these blocks are saved to external storage. This external storage needs to be immutable. This needs to be an immutable storage. The application can use the storage to check the integrity of the data, but this can also be triggered inside the database. So, another kind of table, append-only ledger table. So, no update is accepted. No update is accepted in this kind of table. No need for a history table. No need for a history table on the append-only ledger table. The view is less useful. On append-only ledger table, we have no updates, no deletes, so the view is way less useful for the append-only ledger table. So this is the scenario of the append-only ledger table. One item is missing in this scenario, is the history table. The append-only ledger table doesn't have a history table. The history table is not here. So it doesn't have a history table. So Azure SQL Ledger System Tables. System tables. We have tables which record every transaction and every block that will be registering the changes in the database. We have transactions, and these transactions will generate hashes, and the hashes will be saved in blocks. These two tables are the base, the core tables that I just illustrated on a previous slide. Here, underneath the ledger table. They are underneath the ledger table. So, besides these two system tables, we also have some tables to check history about table creation and column creation, because these history tables, they are a bit complex to read, and The user history table of Ledger will not show us information about table creation. So we have a special system table to record table creations and change on the schema. And we have another special system table that tells us where is the external location. We saw during the provisioning that we specify external location to save our ledger data. So we specify this external location, the external location saved on this system table, database ledger digest locations. So after seeing this, let's go to a demonstration about SQL Ledger. So I have a database already provisioned this database called SQL Days Ledger Malta. SQL Days Ledger Malta. I'll start creating a schema. Created a schema, and I'll create a ledger table. This is an updatable ledger table. Since I'm not saying in opposite, the default is an updatable ledger table. And a view will be created for every ledger table, a view will be created, and I have the option to specify the name of the view. So let me create the table, and let's check how these will appear in our SQL database. Let me open here tables and views. So this is the result of one table creation. Let's analyze this. We have here the table I created. This is, let's say, the main table. That's the table I was intended to create. For this table that I created, Ledger creates a history table to keep the history of records which are not current anymore to this table. So Ledger keeps a history of this table. So it creates another table. It's using a pattern of name Ledger history for and the object ID to keep the history of this table. And besides that, I said before, querying this history table can be quite difficult. It's not easy to make a query over this history table. So Ledger creates for us a view that makes the query of the result easier. Using this view, we can easily see the operations which happen over this table. We can see all the operations over this table. So we just saw this, and then we can check ledger transactions, and we can see that a transaction was executed. Was executed is the transaction 1172. This is transaction related to the creation of the table. The transaction 1172 has a block, generated a block. The block ID is 0. It's my first table created in this database, my first operation in this database. So the block ID is 0. This block ID is 0. I can check the block, but this is even a more technical detail, and see that the block ID 0 exists, the transaction hash, and block size. And this is the first block created by Ledger. And this is saved in the database, is saved in the database, but as I said before, asynchronously, this is sent to an external storage. I use Azure Storage Explorer to illustrate that. I have here an account. The database is configured to send the history to this storage account. I'm using Azure Storage Explorer. If you have any question about these tools and some details about the storage, please ask me, send me a question, and it will be a pleasure to reply. So, here we see that inside the storage we have a folder for the server with the name of the server. Then inside the folder of the server, a folder for the database is created, SQL Days Ledger Malta. Then I can get into the folder of the database, and then I see a specific folder about the date and time of creation of this database. There is a very interesting reason why this second level folder is created, but I will not dig into details. It's related to backup and restore. And then we see a single file. At the moment, we have a single file created here containing the blocks. And in fact, I have one single block. I can download this file. It's starting to download the file. Let me open it. Notepad. And we see the file is on JSON format. The file contains the block ID 0 for ledger and contains the hash created for this block. Great. Okay. So we can check the ledger history table, but the ledger history table is empty. I even inserted any record in the ledger history table. Whatever updating a record, the ledger history table is completely empty. Let me also illustrate that the view that shows us the operations which happen in this table, ledger view, is also empty. Why? Because the create table operation doesn't get into the view or the history table. That's why we have two special system tables, sysledger table history and sysledger column history, to tell us the history of table creation. So we can see a table has been created on the schema, and the table name, the view name, view schema name, and the schema name of the table, and which transaction contains the creation of the table 1172. And we can also see the ledger column history to see the creation of the columns. Each creation of each column is an operation inside this transaction, and these operations get a sequence number. These operations get a sequence number inside the transaction. Okay, let's execute some inserts and see what happens. So I insert two records. You know about the goal in the middle, what difference the goal does. If not, send me a question. So I'm executing these two inserts. Let's check the table, and you see the records have been inserted in the table. I have two records inside the table now. This table is a table about parts. An example about tracking parts and identifying which car these parts were used, the serial number of the part, and in which car these parts were used. And these inserts generated transactions. These inserts generated two transactions, 11,997 and 1,200. Two transactions. But these two transactions were inserted in a single block. A new block was created, block 1, and the two transactions were inserted in a single block. What's the usual rule for the transactions to be inserted in a single block or to be inserted in different blocks. The hash is generated every 30 seconds. If the transaction happens in an interval of 30 seconds, they will be in the same block. If they are away from one from another more than 30 seconds, then they will be in different blocks. I can query the ledger blocks and see that now we have 2 blocks. It's interesting that the blocks have the previous block hash. This is very important because it's linked to the link chain idea. Each block it also involves the hash of the previous block, also containing the hash of the previous block to gather it. But I'll dig into more details soon. The history table is still empty. Why the history table is still empty? The history table is empty because the idea of the history table is to receive records that are not more current in the main table. When a record is updated, the old values are not more current in the table, so they go to the history table. When the record is deleted, that record is not anymore current to the table, so it goes to the history table. But at the moment I only did insert, so if I only did insert, the history table is completely empty. Then we have the parts ledger view. Here I can see a complete view of the operations. The parts ledger view joins the information between the history table and the main table. I can see those information joined together to show me the operations which happen in the table. So I can see that at the moment what happened were 2 insert operations. They were in different transactions. And the ledger operation type 1 and ledger sequence number both have ledger sequence number 0. It means each transaction had only one operation. It's interesting to not mix things. One thing is the ledger sequence number being 0. Each transaction has only one operation inside the transaction. Another thing is about the ledger blocks, ledger transactions and blocks, where I have 2 transactions in the same blocks and I have the transaction ordinal inside the block, making a sequence of the transaction inside the block. These are different information. One thing is the sequence of the transaction inside the block generating a hash. Another thing is the sequence of the operations inside the transaction. These are different informations. Let's execute now an update, and you'll get some interesting and different results from an update. This is an updatable ledger table, so we can update the information. I'm updating the information on the table. So now one of the car IDs is not null anymore. So one of the car IDs is set to 2. Then I can check the history table. Once I updated a record, an old version of the record goes to the history table. An old version of the record goes to the history. And with the old version going to the history, the car ID on the history is null because this is the old version. The new version got a value. The old version has the car ID null. And I have here the special fields created for the table. The table and the history table have these special fields. I didn't ask it for these fields to be created. They were automatically created for me. These are fields which mark the start and end of a record. What this means? The start of a record is the transaction that turned this record into a current record. And the end of a record is the transaction that made that record not current anymore. And for each start and end, we have two informations. We have the transaction ID and a sequence number. The transaction that made the change on the record and the sequence number of the operation in the transaction that made the change in that record. Okay, so I have this information, and in the history we see all the information filled. The record started on transaction 1200, and the record ended on transaction 1212 on an update. This is the history, okay? And then I said a better way to check the history is to query the view. Let's query the view and we see this history in a better way. It's not perfect. It can appear a bit strange, but it is still in a better way. First, we have the two initial inserts that we did inside the ledger table. We did two initial inserts. And then we discover the update is not recorded as a history of a single update. The update is recorded as two operations, an insert and a delete. So we see an insert of the new values of the record, and we see a delete operation of the old values of the record. And this forms an update operation. It's in the same transaction, 1212, and we have two sequence numbers. The insert operation has sequence 0, and the delete operation has sequence 1. So the update on the history of operations was broken down into different operations. Then we can check the transactions. We'll not see anything different in relation to this. We have the 1212, which is the block ID 2. Block ID 2 has the transaction 1212. There is only one transaction on this block, okay? And we can see the block IDs. Okay, now we already have 3 blocks. Let's move a bit ahead. Let's make another example with update. Now I put updates in a single transaction. And now I'm updating both records, and I'm putting the updates in a single transaction. So let's see what happens with the history. The history always contains the records which were not current anymore. So I have 3 records in the history. The first one is the record 2, is the result of my first update, where I filled the car ID for the record 2. And now I made an update on 2 records in the table. So I received again the records 1 and 2. So on the history, the key can be duplicated. Of course, this record can change many times. And now I'm seeing this is the old. A new value has been created for this record. Let's check the view. As I explained, the view is a better way to see the history. And again, we can see the update is converted in insert and delete operations. But now we have a transaction with 4 operations. 2 sets of insert and delete operations because I included the updates on the same transaction. I included the updates on the same transaction, so I have 2 sets of insert and delete operations. Okay, we can check the ledger transactions. We see our transaction 1218 on block 3. Block 3 has only this transaction, 1218. And we can check the blocks. Now we have a total of 3 blocks, and we can make something interesting. Let's check our digest file again. Let me open the file in the storage again. So these are the blocks that I have. And we can notice the relation between the previous block hash. We can't find this relation about the previous block hash inside the system table, but we can find this relation inside our file. So the second block has as previous block hash the hash of the first block. The third block has a previous block hash, the hash of the second block. And the fourth block has a previous block hash, the hash of the third block. So we can't make this relation directly on system table, but if we compare this information with the file, we can see the relation happening. So each block gets the previous block hash and continues the processing. So creating a chain of the blocks, and this improves the performance a lot. I'm talking about this in a very superficial way, but later I will provide a link if you would like to dig deeper on how this is done. Okay, let's check the history again. So we saw the update transactions here. So our data is updated. So car ID is 3 for all our records. Now, to complete our examples, let's try a delete. I'll insert a delete inside the transactions. A simple delete. And check the transactions. Now I have a block 4. This block contains the delete. And then I'll make another insert, a simple insert inside the transactions. If I execute the transactions again, now I have a block 5, block ID 5, and checking the history. So, interesting to mind the difference. The transaction 1218 has sets of insert and delete, which were in fact update operations. But the other two transactions that we have, and they have different transaction numbers, they are isolated delete operations of a record and an insert operation of a record. Isolated, they are not an update operation. They are a delete operation and an insert operation of a new record. Okay, so we saw about this. This is an updated ledger table. Now let's see an example with an append-only ledger table. With a new schema. This example, which I'm using with an append-only ledger table, is a traditional example of a wallet. This is very used in iGaming scenarios and could be used in other scenarios as well. A wallet where we have the user ID, the operation executed wallet, which could be a credit or a debit operation. a timestamp about when the operation happened, and the amount of this operation, of the credit or debit. What is this wallet append only? I'm asking it. I'm asking this wallet to be an append only wallet. So I'm asking for this, and I'll create the table. An interesting detail for us to note here. Let's first check the result of the creation of an append-only table. What can we note here? The append-only table is created. A view for the append-only table was created as well. But there is no history table for this one. Why? Well, the history table is to store old records, records which were updated or deleted. But this table doesn't support update or deleted in any way. This table doesn't support that, so there is no sense in having a history table for it. That's why the append-only ledger tables don't have a history table. A history table is not created for them. And we can check the transaction of the creation of this table. Ledger table history. And we see that in a single system table, ledger table history, we have the transaction, the creation of the two ledger tables that we created, path tracking and wallet. And different transactions ID, 1172 and 1233. This means there is a single set of transactions. I can check these transactions and they are all together. 1233, it's here. 1233, together all other transactions created the block 6 of ledger. What this means? This means that Ledger don't operate on a table level. Ledger operates on the database level. Every transaction inside this database is generating the transaction records, the blocks, and the digests. Every transaction in the database is generating this. So let's make a sequence of inserts inside this append-only table. Okay. And we can check our data. Here I'm checking, in fact, the view. The view for this table, it will show the operations for me. It will show the insert. Each insert has its own transaction in this example. But if I dig deep database ledger transactions, I will discover that since I executed them all together in a single moment, they all got inside the same ledger block. The ledger block ID 7 contains all these inserts, and you can see the transaction ordinal for all these inserts for a single block. So one single block can contain multiple transactions. Yes, it can. This order select is a bit complex, but it's a side note. It's not related in any way to Ledger. Since I'm making an example with wallet, I included here a select where I can build a running total for the wallet and see the running total of the users. So I can see this select and see the running total of the users. So I can see the operation amount and running total for user 1, for user 2, and user 3. The point is that we could do this before. Of course we could do this before. But how could we ensure that our data would not ever be tampered with? Before we couldn't. That's why many gaming companies were looking for third-party solutions to solve this problem, to ensure that a critical information like a wallet for a user would never be tampered with. But now, using Azure SQL Ledger, we can solve this problem inside SQL Server and in a simple way. And this is an append-only ledger table. So if I try to make an update on this table, it will fail. It will not allow me to update this table. I cannot update the table. It's not an updated table. That's it. It's not an updatable table. If you'd like to verify if my database is correct, verify the integrity of my database, I can use a storage procedure, verify database ledger from digested storage. I use the information on the storage to verify the integrity of my database. And the information of the storage, I need to recover where is the storage. So there is a system table called sysdatabase ledger digest locations. This script recovers this information and triggers the verification of the integrity of the database. So last block verified 7, and everything is okay. No error is pointed to us. I can check the blocks and I can see that my last block is 7. So everything is okay with this database until now. Let's create a problem to this database. Let's make a problem. Let me download this file. I'll download this file inside folder called SQL Days. This is the correct file. This file is correct. I'm downloading it inside this folder, SQL Days. In fact, this folder that we are seeing here is SQL Days. Correct. This is a mapping of a file share in Azure. I just shared in the conference application an article about mapping an Azure file share. This is a map of the file share in Azure. More than any file share is a mapping of a Cloud Shell file share to make this process easier, so I can simulate a damage on my environment. Of course, this is not the correct way for that, because the correct way is that the storage should be immutable, but my storage is not immutable. So I will simulate this problem. How I simulate this problem? I open Cloud Shell. Why am I taking so difficult steps? Why I don't open the file in Notepad? Because if I open the file in Notepad, the content type of the file changed and Ledger doesn't accept the file anymore. I need to edit the file, let's say, in a low-level editor that will not change the content type of the file. So I'm using Cloud Shell, cd cloud drive, cd damage, cd days, and cd damage. This is the folder, cd damage. This is the folder that I created. My file named 1 is inside the folder. I use the Cloud Shell editor to edit this file. The file is called 1, and the Cloud Shell editor will open the file to edit. You are seeing this file is a blob. It's quite annoying. Yeah, it is. It's quite annoying to edit this file because this file is really a blob. And my purpose here is to tamper with the block 7 and block 5. I'll tamper with 2 blocks, block 7, block 5. So now, okay, so where I was. Sorry, page unresponsive. So let me get back to the point I was. This is the hash of block 7. I'll change one letter, just one letter. And yes, this is annoying. This is a regular test. This is very annoying, but this is not a regular task. Okay, then I'll get back, reverse, go back. I will skip the block 6. This is block 6, and I don't want to tamper with block 6. So skip it, and now I'm block 5, and I want to tamper with block 5. So using the hash, and let me again, as soon as the window allows me to, change one letter. Okay, so I tampered with block 7 and block 5. Save. Close the editor. So this file is not correct anymore. Not correct anymore. So if I execute the ledger verification, oh, sorry, I missed one point. I tampered with the file on my personal storage. Now I need to put the file on the correct place. I missed this step. Let me clone this file here as 2. Delete the one. This trick to clone and delete the original, and now I will upload my file 1, is because this is created by Ledger use hierarchical namespace disabled. Hierarchical namespace disabled doesn't allow folders. So this is a trick to avoid problems. So I will upload the damage file, the file that I destroyed. It's an append blob. It's not a regular block blob. It's an append blob that only accepts append. And many details that I mentioned may be triggering some questions please send these questions to my director. Let's talk about this. Let's discuss about these questions. Okay, so I uploaded the file 1 and I'll delete the file 2, which is the clone that I created. Yes, I'll delete the file 2. And now I'll keep only the file 1, which is the damage file inside the ledger storage. And now that I have the damage file inside the ledger storage, I'll check the integrity of ledger, and ledger tells me what's wrong. Of course, I get an error, but I get a very specific error telling me that block 7 and block 5 are tampered with. What I need to do? I need to identify the transactions and the tables affected by this. And to verify the transactions and tables affected by this, I need to verify where this block, the transactions on this block. So I recover the transaction IDs from the sysledger transactions which are involved on these blocks, and check if the ledger view contains these transactions. If the ledger view of the wallets contains these transactions, the wallets it's tampered with. If the pass ledger view contains this transaction, the pass is tampered with. So I execute this query and it will tell me that both are tampered with. Yes, because that's what I did. I tampered with the 7 block, which is for the wallets table, and I tampered with the 5 block, the 5th block, which is for the pass table. If I had tampered with 7 and 6, it would be only the wallets table, not the pass table. But I tampered with both the wallet and the pass table. So I destroy both, and I can identify exactly the transaction which is affected by this problem. I can identify exactly the transaction affected by this problem. Okay, let's get back to our PowerPoint. Let's talk about external storage. I hope I can pass just 1 or 2 minutes. External storage. We are using the Azure storage account. This is one of the possible storage. The other possible storage is Azure Confidential Ledger. Azure Confidential Ledger is a new Azure service which is also in preview. Azure Storage Account. When you use Azure Storage Account, the hierarchical namespace is disabled. This storage account is created automatically by SQL Ledger, and it keeps the hierarchical namespace disabled. It uses an append blob. The blob is an append blob. The content type is application octet string. This makes it very difficult to edit this in a regular editor like Notepad. Notepad will destroy this file. So you need a special editor to edit this, and the Cloud Shell editor works. You may find other useful editor for that. Recommended, apply a immutability property. Many people may not know, but Azure Storage Account has a immutability property to ensure that the data included in the storage can't be changed anymore. It's immutability policy. How is this applied? When I'm on the window looking to the containers, on the menu I can use access policies, and then one of the access policies is the immutable blob storage. That's why the hierarchical namespace is disabled, because the immutability policy is only available with the hierarchical namespace disabled. Only with the hierarchical namespace disabled, the immutable blob storage is available. Then we add a policy. We need to add a time-based retention policy. It needs to be a time-based retention policy, because a time-based retention policy will allow us to use append blobs. And we need to use append blobs, so we sending data, but the data will never change. So we need to use a time-based retention policy. We specify a period, but it doesn't mean that when this period expires, the data will be able to change the data. We will not. We will not. The period is a configuration for the time-based retention, but we will still not be able to change the data. The period defines the permission to erase the data, not to change it. The data is immutable. Azure Confidential Ledger is our other option for storage, and the second option for storage is even more trustworthy, but is an additional service. It's in preview. I have no information about costs of the confidential ledger. It's a service to store immutable data. Confidential ledger has its use, can be used by itself, and is a great partner of Azure SQL Ledger because the digest from SQL SQL Ledger. SQL Ledger is still in preview as well. This is a view of the architecture of the confidential ledger. We have the confidential ledger here talking with applications, and it uses a backend blockchain cluster to store the information. Some reference about all that I talked. These references are not just about the same that I talked about. These references are quite interesting and important to dig way deeper on SQL Ledger. The SQL Ledger documentation on Microsoft website, okay. SQL Ledger articles that go very deep on SQL Ledger, it's a good start. And the SQL Ledger white paper. If you would like to blow your mind about how SQL Ledger works, go to the white paper, a 13-page white paper which explains deeply how SQL Ledger works and how SQL Ledger prevents many different kinds of attacks over your data. And also about the SQL Ledger SQL Confidential Ledger documentation, the Azure Confidential Ledger documentation about this optional external storage which we can use. So my contact again, it will be a pleasure to keep in touch. So get my contacts. This session will be recorded so you can come back to this slide and get my contacts. It will be a pleasure to keep in touch. This second link is a newsletter. You can subscribe for it. Thank you again for the sponsors of this session. And please send many questions to my direction and I'll be answering all of them. I understand that during the session I mentioned many details and technologies that may not be so clear in our scenarios and questions, and I'll be answering all of that session. I hope you like it, and please fill the polls with the feedback about the session. I would like to know what you think about the session. If you like it, if you don't like it, please fill the polls. Thank you very much.